In this segment, you'll be able to recognize cooling system tests and procedures for conducting them. You'll be able to interpret results from antifreeze and coolant conditioner concentration tests and determine an appropriate corrective action. Because the cooling system is so critical to the life of the engine, there are several test procedures to ensure the cooling system is operating properly. Check the coolant level frequently. The cooling system can be under pressure. Loosen the cap slowly to prevent injury. Always check the operation and maintenance manual for the proper fill level. The coolant level should come up to the bottom of the filler pipe. There are various methods to test the coolant. A Caterpillar coolant and battery tester tells you the freeze protection provided by the solution. To use the coolant tester, open the hinged cover and clean the sight glass. Place a drop of coolant on the glass. Close the hinged cover. Hold the tester up to natural light. Make sure the hinged cover is on top of the tester. The freeze protection temperature is indicated by the line between the light and dark portions in the sight glass. Read the temperature alongside the ethylene glycol scale. To determine the antifreeze concentration using the results from the coolant tester, obtain Caterpillar SEDB 0518-07, Know Your Cooling System, or Caterpillar SEDB 0978-01, Coolant and Your Engine. Refer to the freezing point curve chart located in either publication. Next, locate the freeze protection temperature from your test result on the chart. Trace a line from the temperature on the left scale of the freeze protection curve. Then trace another line from the intersection point on the freeze curve to the antifreeze concentration on the bottom scale. Read the antifreeze concentration. Another method to test antifreeze concentration requires the use of the coolant test kit. Floating balls in a dropper provide an approximate concentration of ethylene glycol. To perform the test, fill the dropper with coolant to the test line. Observe how many balls float. Compare your test results with the instruction card from the test kit. In general, the more balls that float, the higher the concentration. You should determine the antifreeze concentration before you test the coolant conditioner concentration. To read the test results accurately, you must know how much antifreeze is in the coolant. To test coolant conditioner concentration, use the Caterpillar test kit. To perform the test, put 1 milliliter of coolant into the vial. Add water to the 10 milliliter mark. Add 3 drops of solution A and mix it. Add solution B 1 drop at a time, mixing after each addition. Count the drops. When the color changes from red to green, gray, or blue and stays that way, the test is done. Compare the number of drops of solution B you added to the vial to the numbers on the chart. The antifreeze concentration of the sample determines which scale to use. Read and note the concentration of coolant conditioner. After measuring the concentration of antifreeze and coolant conditioner, determine whether the coolant mix needs adjustment. If the coolant level is low, but the concentrations are acceptable, mix new coolant and fill the system. If the concentrations are too high, drain some coolant from the system and add the correct amount of new coolant. Retest the new mixture after operating the engine long enough for the coolant to get fully mixed. Do not add more conditioner if the coolant conditioner concentration is acceptable. During maintenance of the cooling system, visually examine the coolant. Oil in the coolant, shown in sample number 1. Fuel in the coolant, as in number 2. Or debris in the coolant, 3, indicates a problem that needs investigation. If the coolant shows evidence of a leak, inspect the engine. Leaks provide a way for air and foreign fluids to enter the cooling system. Excess air reduces cooling capacity and can produce cavitation erosion. Test the radiator cap during your routine cooling system maintenance. The test makes sure the cap will open at the correct pressure. The opening pressure is stamped on the cap. To test the pressure cap for the pressure that makes the cap open, first remove the cap from the radiator. Next, put the pressure cap on the recommended cooling system pressurizing pump group for the engine. Operate the pump and look at the gauge for the exact pressure that makes the pressure cap open. Make a comparison of the reading on the gauge with the correct pressure at which the pressure cap must open. If the cap is defective, install a new one. When you perform major maintenance on a cooling system, test the regulator to make sure it's working properly. A regulator failure can cause overheating or overcooling, which may result in serious engine damage. Examine the regulator for external damage or rupture. Then test it to make sure it opens at the proper temperature. Immerse the regulator in a container of water. Suspend the regulator so it does not touch the sides or bottom. Note the opening temperature stamped on the regulator or in the manual. Heat the water to that temperature. The valve should be fully open when the temperature reaches the stamped value. Measure the opening distance. Check the specifications and replace the regulator if necessary. In this segment, you will learn when a scheduled oil sample should be taken and the type of information it provides. You will understand why monitoring oil level, oil pressure, and oil consumption are important service procedures. There are several system tests you can do to make sure the engine lubrication system is performing properly, such as oil pressure, scheduled oil sampling, and oil level. Every time you start the engine, check the oil pressure on the oil pressure gauge. Oil system pressure can indicate whether the components in the system are operating normally. For the most accurate oil pressure reading, attach a pressure gauge to the recommended oil pressure test site. Start the engine and read the gauge. Compare the reading to specifications in the service manual. Every time you change the oil, you should collect a scheduled oil sample, SOS. The oil sample is sent to a lab for analysis. An SOS provides information on engine wear and oil condition. For more information on SOS and sampling procedure, please review General Maintenance Procedures later in this course. Check the oil level daily to monitor engine oil consumption. Diesel engines do consume oil, and you'll have to add new oil periodically. This is normal. If you check the level every day, you'll be able to spot changes in oil consumption, which could indicate a problem. You and the operator share this responsibility. To check the oil level, pull out the dipstick and wipe it off. Insert the dipstick back into its port. Pull the dipstick out and read the oil level. Many dipsticks have different markings on each side. Make sure to read the right one. If you measured the oil level with the engine stopped, read the side of the dipstick that says engine stopped. If you measured the oil with the engine running, read the side of the dipstick that says engine running. On each side of the dipstick are two lines. One line says low or add, and the other says full. In many cases, the distance between the lines indicates a quantity of oil, such as a gallon. Therefore, if the oil level was on the low mark, you could estimate that the engine needs a gallon of oil.
Some dipsticks have no low or full markings when the engine is shipped to the customer. This is because the engine may be mounted at an angle, and a pre-marked dipstick would be inaccurate. In a case like this, the operator must mark the dipstick so it indicates the correct oil quantity in his engine. Check the dipstick to make sure it's the correct part number for the engine. It's not uncommon to find that someone has switched dipsticks. This can lead to under- or overfilling because the stick reads the wrong level. If too much oil is added, the design of the engine will blow oil out of the seals. As the oil level increases beyond the specified level, it covers the front and rear seals on the crankshaft. While the engine is running, the seals spill the excess oil. This leads to the impression that the engine is consuming too much oil. In this segment, you will learn about air intake and exhaust system tests, such as boost, inlet restriction, and smoke density. You'll also learn the step-by-step procedure for a snap-idle smoke test. Any change in the flow of air or exhaust through the system will affect engine performance. A variety of tests can be used to determine if the air intake and exhaust system is functioning normally. These tests include checking the air filter indicator, checking boost, smoke density test, and checking for an inlet restriction. Some engines are equipped with an air filter indicator. The indicator can be mounted in the cab, the engine compartment, or on the air filter housing. A diaphragm inside the indicator moves in response to vacuum inside the air filter. The greater the vacuum or restriction, the higher the diaphragm is pulled. You can reset the diaphragm by pressing the reset button. Since the air filter indicator can be reset any time, there may be an inlet restriction even though the indicator appears normal. If the indicator diaphragm is in the replace zone, inspect the air filter element. It is best to rely upon visual inspection of the filter to make sure it's not clogged. If the filter is clogged, replace it.
To determine if enough air is entering the intake manifold, use a boost pressure test. Boost is measured with the Caterpillar engine pressure gauge group. Boost is a measurement of the difference between atmospheric pressure and the pressure within the intake manifold. To measure boost, make sure the engine is off. Connect line and adapter to recommended test plug on intake manifold. Check service manual for exact location. Connect line to the compound pressure gauge. Run engine until it reaches normal operating temperature. Load the engine. Read boost from gauge and compare to specifications. Boost pressure can be affected by air restrictions in the filter or leaks between the compressor and intake valve.
Always check the service manual for the engine you're working on to determine which pressure gauge to use. The H2O gauge, shown in the previous demonstration, may not be appropriate for some boost measurements. Smoke tests measure how thoroughly the engine is burning fuel. The smoke density tool works by gauging the amount of light blocked by smoke as it passes through a sensor. Density results are displayed as a percentage. For example, 0.4 means 4% of the light is blocked by smoke.
Smoke density is measured using a snap idle test. With the transmission in neutral and the engine at low idle, press the accelerator down 3 times to clear the exhaust stack. Connect the sensor to the top of the exhaust stack and connect the other end of the line to the smoke meter. Turn the meter on. Accelerate to high idle 3 times. Note the smoke density readout each time. Average the 2 closest peak opacity readings. Use this smoke number to compare the engine to the allowable smoke standards.
An inlet restriction can affect engine performance. Inlet restriction tests check the pressure drop across a component. The most common cause of a restriction is a clogged air filter, but other components can also become plugged.
To perform an inlet restriction test using the Caterpillar engine pressure group, make sure the engine is off. Connect a line to the test plug on the air filter housing. You may have to remove the air filter indicator. Refer to the special instructions for exact location. Connect the line to the vacuum gauge. Start the engine and read the gauge. Compare the results to manual specifications.
In this segment, you'll learn the procedure for measuring dynamic timing and be able to interpret the results of a dynamic timing test. You'll learn the procedure for adjusting timing advance start and stop. You'll learn about pin timing, and you'll be able to identify test results that indicate a failed injector. Because the fuel system is so critical to engine performance, many tests have been developed to make sure the components are working properly. Many of these tests are diagnostic or are used after a complete engine overhaul. Some tests are performed on a routine basis. This segment covers common tests used during performance testing or during an overhaul. The tests covered in this segment include dynamic testing, adjusting timing advance, pin timing, and nozzle testing. Dynamic timing measurements provide information on fuel injection for all cylinders. Dynamic timing indicates whether reference timing and timing advance start and stop are within specification. Dynamic timing also reveals whether the timing advance unit is operating normally. Before you conduct a timing measurement, plot the timing specifications for the engine on a graph. The timing specifications are available from the service literature system. Use the recommended timing indicator for the engine model. The indicator uses transducers to measure two signals: when fuel is injected and when the piston reaches top dead center. It calculates the time difference between the two signals and displays a reading in degrees before top dead center.
To perform a dynamic timing measurement on a 3406, attach fuel line transducer to number 1 or number 6 fuel injection pump bonnet. Attach the TDC transducer to flywheel housing. Both transducers must measure same cylinder. Connect the timing indicator to DC power source. Start the engine and check fuel pressure. Let the engine warm up to operating temperature. Begin dynamic timing measurement at 1000 RPM. Plot timing every 100 RPM up through maximum range. Plot timing every 100 RPM from maximum engine speed down to 1000 RPM. Connect all points with a line.
Your timing measurements must fall within the specified range for reference timing, timing advance start, and timing advance stop. Timing advance must occur smoothly throughout the specified speed range. Sudden jumps indicate component problems. After you've performed a dynamic timing measurement, you'll be able to evaluate automatic timing advance unit operation. You cannot truly evaluate timing advance operation without performing a dynamic timing test. The timing points must fall within the specifications for number 1, reference timing, 2, timing advance start, and 3, timing advance stop. You can easily tell if timing advance start and stop is too early, shown in number 1, or too late, as in number 2. Timing advance start and stop can be adjusted if necessary.
To adjust the timing advance, remove the cover and loosen lock nut in the center of timing advance unit. To increase timing advance start RPM, turn large screw clockwise. To adjust timing advance stop, loosen smaller lock nut and turn the set screw. Turn it clockwise to decrease the stop RPM.
If you adjust timing advance start, you must also adjust timing advance stop. When you turn the start screw, number 1, the stop screw, number 2, rides along with it, which resets timing advance stop automatically. You must back out the stop screw to reset the timing advance stop to the correct RPM. After adjusting timing advance start or stop, recheck the dynamic timing. If dynamic timing indicates that the reference timing of the engine, number 1, is not within specification, you should check the mechanical alignment of the components. Pin timing is the factory reference point and is based on the correct alignment of the engine components.
Pin timing physically aligns engine components with metal pins. To perform the procedure, place number 1 piston at TDC on compression stroke. Pin the fuel injection pump housing to fuel pump camshaft with timing bolt. Pin the flywheel to flywheel housing with timing bolt. If both pins fit at the same time, timing is correct.
Correct pin timing means you can fit the timing pins into the fuel pump housing camshaft and the flywheel housing and flywheel at the same time. Fuel nozzles should be inspected and tested before installation. During an overhaul, all nozzles are usually tested. Nozzles must be tested off the engine on the recommended test stand. Nozzles are tested for valve opening and closing pressure, valve seating, back leakage, and spray pattern.
Nozzles that do not open should be replaced. Poor spray patterns indicate failed nozzles. Replace nozzles that do not mist fuel properly. Erratic nozzles should be replaced. Replace the nozzle if too much fuel leaks off. Replace nozzles if too little fuel leaks off.
After completing this topic, General Safety Guidelines, you will understand the basic safety guidelines which apply to all diesel engine shops. You will know about personal protective devices, environmental safety guidelines, and safe engine work practices. In this segment, you'll learn about personal safety devices which may be required in a diesel engine shop. There are safety warnings everywhere. Read them and understand all safety precautions and warnings for the engine and for any products or tools you use on it. Most accidents are caused by failure to observe basic safety rules or precautions. By following a few general guidelines, you will work more safely. Do not take safety precautions lightly. The types of injuries that could result from improper procedures are serious and could even result in death. If you use a tool, procedure, or operating technique that is not specifically recommended, make sure that it is safe for you and others and will not damage the equipment. Caterpillar cannot anticipate every possible situation that might involve a potential hazard. Use your best judgment to ensure that your actions will not injure you, others, or damage the equipment.
There are many things you can do to protect yourself and others from injury. First and foremost, become familiar with the safe job practices and safety equipment requirements for the work you are performing. If you do not know what they are, ask for help.
There are several protective devices such as safety glasses, rubber gloves, steel-tipped shoes, earplugs, hard hats, and aprons that may need to be worn depending on the work location. Be familiar with the safety equipment requirements for the work area.
Some chemicals used with engines can be hazardous. Battery acid, for example. Become familiar with the hazardous chemicals used in your work area and know what personal safety devices you should use when working with them. Mines, construction sites, and other hazardous or noisy work areas may require special safety equipment. Gloves to protect your hands, hard hat and steel-toed boots to protect your head and feet, and earplugs to block out the loud noise. Always use the protective devices appropriate for the job you are doing. Never wear jewelry, loose-fitting or torn clothing that can get caught in moving parts. This technician could get his shirt caught in a moving component of the engine. Although it may seem a quick way to clean up your clothes and skin, the pressure of compressed air to spray away dirt could force oil and fuel particles under your skin. So do not clean your clothing or skin with compressed air. This technician could really hurt his back lifting this way. Do not lift heavy equipment or components without help. Use a hoist when necessary. Remove rings before doing mechanical work because they can get caught in moving parts and can short-circuit electrical connections and cause severe burns. Always use recommended procedures and equipment when climbing on and off of machinery.
You can protect yourself from injury by using good work habits. Be careful around the engine. If you get a hand or finger caught when moving heavy components, you could really hurt yourself. It's also easy to slip and fall when climbing on or off machinery. In this segment, you will learn about safe and unsafe work environments. You'll also learn the procedures and guidelines required to prepare the engine for a service procedure. Environmental safety means keeping the area you work in free of hazards.
Keep your work area well ventilated to minimize exhaust fumes. If you have permanent exhaust systems, use them to vent fumes outside. Clean up any spills immediately to prevent contaminating the environment or causing injury to someone who might slip on them. Put working tools and equipment in their proper place.
If the engine is in a truck, block the wheels. If the engine is used in some other type of equipment, block or stabilize hydraulic and mechanical systems. Put warning tags on the engine and in the operator's compartment. Tag the steering wheel so that it's clear that work is in progress and that no one should try to start the engine.
Be sure to observe all no-smoking areas, since a cigarette could cause an explosion by igniting hydrogen gas fumes in battery compartments.
In this segment, you will learn the common safety precautions which should be followed before performing any service procedure. You'll also learn the proper test procedures for safely checking pressurized systems and working on a diesel engine. Because some diesel engine systems generate high pressures and temperatures, special precautions are necessary to prevent injuries. Always follow the service manual procedures for the specific engine. Although there are some exceptions, almost all service procedures should be done on a cool engine. Batteries should be disconnected and isolator switches turned off before starting work to prevent accidental starts and components shorting out. It also protects you from burns and shocks.
Never use your bare hand to check high-pressure fuel lines for leaks. Fuel under pressure can pierce your skin and cause blood poisoning. Use a shop towel to help test for leaks in pressurized systems. Wipe the suspect fitting and watch for leaks from a safe distance. Never bend or hit a fuel injection line when you remove or install it. The lines carry fuel at extremely high pressures, and any damage increases the risk of leaks. Follow recommended procedures when using lifting devices. Make sure the chains, hooks, and slings are in good condition.
When using lifting equipment, attach the hooks with the hook ends facing out. When the hook faces out, the load is distributed straight through the chain. This reduces damage to the equipment. Attach hoist chains so they are as perpendicular as possible. The more vertical the chains, the more load they can carry safely.
Operate the hoist slowly because the component might start to swing. Positioning the hoist directly over the component reduces the swing.
Make sure the rated lifting capacity is higher than the load. After completing this topic, you'll be able to identify engine information plates, identification tags, and service meters, and understand the types of information available from these sources. You'll also be able to conduct a visual inspection of an engine. In this segment, you will learn how to locate an identification tag and information plate on an engine. You'll also learn to calculate a service interval using hours, miles, and gallons of fuel consumed. Whenever you service an engine, you should always perform a visual inspection. A visual exam will tell you a lot about the general condition of the engine.
On Cat engines, the information plate provides most of the information you will need. Information plates are often located on the intake manifold or valve cover. For the exact location, check the manual.
Electronic engines use plates plus computer software to store performance information. Every piece of data on the information plate is useful when you service or test an engine. The serial number is a unique number which identifies each engine. The arrangement number is a 6-digit number used with the serial number to access the Caterpillar parts and ordering system. Use the performance specification, or 0T number, to access the fuel settings and related information fiche. With the 0T number, you can look up specifications for a particular engine. In addition to the information plate, the serial number and model number are located on an ID tag on the block. The serial number is also stamped into the block.
Make sure you keep the original information plate. The plate and ID tag must match. Otherwise, you could look up information for the wrong engine. Besides the data from the information plate, you have to know how long it has been since the engine was serviced. There are 3 ways to calculate the service interval: service hours, mileage, or fuel consumption. Every engine model can have different service intervals. Make sure to check the service manual to find out if the engine is due for service.
To calculate the service interval using the fuel consumption technique, add the total gallons of fuel used since the last service. Fuel consumption is the most accurate method to determine the service interval because it compensates for engine load. You must have accurate operator logs in order to use this method. To calculate the service interval using the mileage method, take the current odometer reading and subtract the previous reading found in the service logs. In this segment, you will learn the purpose and procedures of a visual inspection. You will learn to identify problem areas when given sample components to inspect, and you will learn the different methods of checking belt tension. Visual inspections tell you about the general condition of the engine. They help identify engine problems before they become engine failures. You need to perform a visual inspection every time you service an engine.
When you perform a visual inspection, you will want to do basic operation checks and inspect the engine systems for leaks and other obvious problems. During the inspection, write down any problems you find. Let your service advisor know about major items. Leaks can appear as wet spots, corroded spots, or stains. On a large leak, you might see fluid dripping or pouring out. Check the battery and case for corrosion, cracks, leaks at the cell covers, and the condition of the posts, connections, terminals, and harnesses. Chalky deposits also indicate a problem. Check the electrolyte level on regular and low-maintenance batteries. You cannot do this on a sealed battery. Finally, check the cables and connections to make sure they're not damaged and are the correct size. Clean the connections and put heavy protective grease on them to stop corrosion. Check the electrical harnesses too. Wiggle them to make sure they're not loose, and look for any frayed wires that could cause a short. You need to inspect the oil pressure, temperature, alternator, and other gauges to make sure they're working.
Always check the oil level and condition.
Check all the cooling hoses and clamps. If they feel soft and mushy or hard and brittle, they should be replaced. Twist, pinch, and squeeze the hoses to make sure they're not too soft or too hard. Wiggle the hoses at the connections to make sure they're clamped on tight. You also need to check the radiator fins. A large area of bent or clogged fins could reduce cooling efficiency. Inspect all the components for damage and leaks. Check the coolant level and also make sure there is no debris or obvious discoloration. Inspect the air intake system for leaks, restrictions, and damaged components. Check the fuel system for leaks, bent or dented fuel lines, and missing clamps. If the engine has belt-driven components, check both the belts and pulleys. Even small cracks and ridges can cause a belt to fail during engine operation. If a belt is worn or loose, components will not turn at the correct speed, which can lead to major engine failure. If one belt is worn, replace all the belts in the set.
To check belt tension with the engine off, twist or deflect the belts by hand. In general, you should not be able to deflect the belt more than the width of the belt, or 1 inch.
You can also use a belt tension tool to get an accurate measurement of the belt tension.
While you're checking the belts, inspect the pulleys for wear, cracks, or damage. Pulley grooves should have flat, angled sides. If a pulley has dished sides or other damage, such as cracks, replace it. Goal of visual inspection: to spot problems before they become failures. After completing this topic, you will understand the maintenance procedures performed on the oil, cooling, air, and fuel systems. And you will recognize the procedures required to change the oil, air, and fuel filters. In this segment, you'll learn the recommended service interval for changing oil and filters. You'll also learn the steps required to perform the oil and filter change procedure.
Changing the oil, coolant, air, and fuel filters regularly reduces wear and prolongs the life of the engine. Changing the oil and filters at correct intervals helps maintain good oil quality.
Different engines have different oil change intervals. Check the operations and maintenance manual for the engine you are working on. The engine may also require a scheduled oil sample. This procedure is explained in detail in a later topic. When you change the oil filter, cut the old filter open and examine the debris trapped inside it. Particles of metal indicate some part of the engine may be wearing abnormally fast.
Large quantities of metal indicate abnormal wear or a pending failure. So if you see this, contact your supervisor. Before you change the oil, make sure the equipment is on a level surface and that it is secure and will not roll. Run the engine until it reaches normal operating temperature, then turn it off. This warms up the oil so it drains more quickly and completely. Remove the drain plug and drain the oil while it is still warm. This removes more debris and suspended dirt from the system. After the oil is drained, replace the drain plugs and tighten them to the recommended torque. Next, remove the filter with a filter wrench. If there is a bypass filter, remove it too. Cut the filter open and examine the debris trapped inside. If only normal amounts of metal are found in the oil filter, install a new one. Make sure the sealing surface is clean and free of gasket material. Install the recommended filter for the engine. Different models require different sizes and sometimes different types of filters. Do not put oil in the filter before you install it. That would introduce unfiltered or contaminated oil into the block, which could accelerate wear. Lubricate the filter gasket and then install it. Spin the filter until the gasket contacts the base, then tighten it 3/4 of a turn by hand. After changing the filters, refill the crankcase with new oil. Check the operation and maintenance manual for the type and quantity of oil. Remember that auxiliary equipment will increase the required volume. Remove the oil filler cap and add the specified volume of new oil. After you fill the crankcase with oil, run the engine at low RPM long enough to circulate the oil and fill the filters. Make sure the oil pressure is normal. Stop the engine and let the oil drain into the sump. Check for oil leaks. Measure the oil level and adjust it if necessary.
In this segment, you will learn the two methods for adding coolant conditioner and the procedures used for each method. You'll also learn the procedures used to perform routine maintenance on the cooling system and those required for a major service. Cooling systems have a different maintenance schedule than air, fuel, or oil. There are 4 checks you need to perform on the cooling system: coolant level, coolant appearance, antifreeze concentration, and coolant conditioner concentration.
Cooling systems are pressurized and take a little while to cool off after the engine is stopped. Follow the safety guidelines in your shop before working on the engine. Loosen the radiator cap slowly to depressurize the system.
Always check the appearance of the coolant. Foamy or dirty coolant indicates a leak in the system.
Check the antifreeze concentration. Use the test kit recommended by the manufacturer. Test the concentration of the coolant conditioner.
If you have to add coolant, make sure it is the proper mix of water, antifreeze, and conditioner. There are two methods to add coolant conditioner, a spin-on element or liquid conditioner.
To change the coolant conditioner element, turn off the engine and let the engine cool. Turn off the inlet and outlet valve and loosen the conditioner element. Clean the gasket or seal and install the new element. Tighten it until the gasket meets the base, then turn it 3/4 of a turn more by hand. Open the inlet and outlet valve. Remove the radiator cap and check the level. Replace the cap and check for leaks. If the engine does not have a coolant conditioner element, add liquid coolant conditioner to the filler pipe. Follow the manufacturer's instructions for the correct amount.
Excessive coolant conditioner creates silica dropout, which can turn the coolant to a thick gel that blocks the coolant passages. Conditioner should not exceed 6%.
After inspecting the coolant, check the radiator cap. If the gaskets are worn or damaged, replace the cap.
A major cooling system service requires 4 procedures: flushing the coolant, testing the regulator, cleaning the cooling system, refill and test.
To flush the coolant, turn off the engine and let it cool. Make sure the batteries are disconnected. Remove the drain plug or open the drain valve. Use an approved container for disposal or recycling. If the equipment has a cab, open the valve to flush coolant from the cab heater. If there is a drain plug on the bottom of the water pump, remove it. Check the water pump breather filter for blockage or debris. Clean all the drain plugs before you install them. Use sealant if recommended. To get to the regulator, remove the regulator housing and manifold from the cylinder head. Open the housing and remove the regulator and seal. If the regulator is damaged or has heavy deposits, replace it. Otherwise, test the regulator. If it meets reusability standards, reuse it. Install a new lip-type seal into the housing. If necessary, install a new regulator. Replace the gaskets and install the regulator housing. Reconnect the hoses and torque all connections to manual specifications. First, fill the system with clean water and cooling system cleaner. Follow the manufacturer's instructions to mix the solution. Install the radiator cap. Run the engine for the length of time specified by the manufacturer. Then stop the engine, let it cool, and drain the cleaning solution into an approved storage container. Flush the system with water until it runs clear. Capture the water with an approved recycling container. Clean and install the drain plugs. Refill the system with pre-charged coolant, no faster than 5 gallons per minute. Once the cooling system is filled, start the engine and run it without the radiator cap. After the engine is warm, check the coolant level. Add more if you need to. Turn the engine off. Inspect and test the radiator cap. Replace it if necessary. Install the cap and restart the engine. Check for leaks and proper operating temperatures. On some marine engines, you need to check the condition of the sacrificial zinc rods. The rods should be checked frequently and replaced as needed.
In this segment, you will learn how to locate and identify an air filter indicator and an air filter on an engine. You'll be able to determine whether the air filter should be changed based on an air filter indicator. Basic air intake service includes inspecting and cleaning the pre-cleaner and the air inlet pipes. Air filters are replaced as needed. Many engine performance problems stem from a dirty air filter. Symptoms such as black smoke, low power, or excessive fuel consumption could indicate a problem with the air filter. There are several types of air filters.
The indicator can be mounted in the cab, engine compartment, or on the filter element. The indicator has a window which is green, yellow, or red, and a scale which displays vacuum in inches of water. As the filter gets dirty, less air flows through the filter. This increases the vacuum inside the indicator, which causes the diaphragm and piston to move. When the piston enters the maximum restriction area, it is time to change the air filter. For engines without an air filter indicator, the operating conditions dictate how often the filter should be serviced. Before you service the air system, make sure the engine is off. This is for your own safety and also keeps unfiltered air out of the engine. If there is a pre-cleaner, empty and clean it and the inlet pipe. Unbolt the filter element from the base. Cover the air inlet pipe to keep the interior of the engine clean. Remove the element and clean the housing. After you clean the air intake system, install a new filter. Make sure it is in good condition. Use a light inside the filter to help check for rips and tears. You'd be able to see the light through any holes in the filter. Install the new filter and tighten the connections. Finally, reset the air filter indicator by pressing the reset button if it has one.
In this segment, you will learn to identify primary and final fuel filters on an engine. You'll also learn the procedures used for cleanable and replaceable fuel filters. Fuel systems require regular maintenance to ensure clean fuel is delivered to the engine. Servicing the fuel system requires several steps. You have to check for water, change the filter, and prime the system to remove air.
Before you begin, turn the engine off and disconnect the batteries. Turn off the fuel supply if the machine has a manual shut-off valve. Before you can drain the water, you'll have to check the service or OEM manual for the location and type of water separator. Once you've located the water separator, open the valve and drain any water that might be present. Drain water from the fuel tanks as well. Check the service manual for the exact location and procedure.
After draining the water from the fuel system, change the primary and final fuel filters. Primary filters are normally located between the tank and transfer pump. The final filter is usually located fairly close to the fuel pump. Do not fill new fuel filters with fuel when you install them. This introduces unfiltered fuel into the engine, which could cause damage. Primary fuel filters are available in both cleanable and replaceable styles. Final fuel filters are always replaced.
To clean a canister primary filter, loosen the bolt on the housing and remove the filter case. Take the filter element out of the case. Clean the filter with non-flammable solvent. Follow the recommended procedure in the manual and remember to clean the case as well. Install the clean, dry, or new filter element into its case. Reconnect the case. Tighten the bolts to the recommended torque. To change a spin-on element, remove the element and clean off the surface of the filter base. Make sure all the old gasket material is removed. And replace the filter with the type and size recommended in the service manual. After you encounter resistance, tighten the filter another 3/4 of a turn by hand. Replace a spin-on final fuel filter the same way. After changing both filters, open the manual fuel supply valve. If the engine has a fuel shutoff solenoid, this step is not necessary. The last step you may have to perform is priming the fuel system to remove air bubbles. The priming pump is usually located on the final fuel filter. Unlock it and operate the pump until you feel resistance. This means the filter is full of fuel. Then lock the priming pump. In most cases, this is all you need to do. The engine normally starts.
In this segment, you will learn when a scheduled oil sample should be collected and learn the 2 preferred sampling sites for an engine oil sample. Scheduled oil sampling, or SOS, provides valuable wear trend information that can tell you about major engine problems before they cause engine failure. An SOS sample should be collected at every oil change. The engine should be warm to ensure that wear materials are suspended in the sample. There are 2 recommended sampling sites, the dipstick port and the oil sample port, the arrow on the engine. Use clean sampling equipment. Dirty tubes or bottles contaminate the sample and give inaccurate results.
To collect a sample, insert the tube into one of the ports. Use the pump if necessary to fill the sample bottle. When the sample bottle is full, disconnect the hose and pump. Cap the bottle tightly. The sample is the first step. Next, fill out the mailing label. Fill out the label completely for the lab to perform the analysis. You will need data from the service order, information plate, operator log, and the odometer.
In this segment, you will learn to identify information obtained through a scheduled oil sampling. An SOS report is a picture of the overall health of the engine. The SOS has 3 types of tests: wear analysis, chemical and physical tests, and oil condition analysis. Wear analysis reveals components that might be wearing faster than normal. Chemical and physical tests detect the presence of water, fuel, and coolant in the oil. An oil condition analysis determines the presence and amount of contaminants such as soot, sulfur products, oxidation, and nitration products. Reading an SOS is quite easy since the report is divided into 1. Owner information, 2. An oil history, 3. Wear materials, 4. Chemical and physical tests, and 5. Oil condition results.